How can I make a volcano from vinegar and baking soda?
Chemistry principles encountered in this experiment, chemical reactions, gases, materials you'll need. Vinegar, baking soda, 2 tablespoons, large bowl, baking pan flour, 6 cups, cooking oil, 4 tablespoons. Salt, 2 cups, plastic bottle, dishwashing soap, red or orange food coloring, or any color, really. Water. The procedure. This is a classic chemistry experiment that you might have done before in school. In a large bowl, first mix 6 cups of flour, 2 cups of salt, 4 tablespoons of cooking oil, and 2 cups of water. Mix these ingredients until they are firm. These ingredients are not involved in the chemical reaction that will make your volcano erupt, but rather this mixture will serve as the rock that forms the structure of your volcano. Place the plastic bottle standing vertically in the pan. Use your hands to shape the rock material from the first step into a cone shape around the top of the bottle. Be careful not to cover the top of the bottle. Fill the bottle most of the way with water, leaving enough space to add a few ounces of baking soda and vinegar. Add a few drops of dishwashing soap to the bottle. This is not part of the chemical reaction that will take place inside the bottle, but bubbles from the soap will help to catch the gas evolved during the reaction between the vinegar and baking soda. Add 2 tablespoons of baking soda into the bottle. Finally, slowly or quickly, if you want a really crazy volcano, add vinegar to the bottle, and prepare to witness the eruption. Be careful though, you should avoid getting this mixture in your eyes or anyone else's, and this combination can make a spectacular mess in your kitchen. The chemical reaction takes place between the baking soda, sodium bicarbonate, or NaHCO3, and vinegar. Dilute acetic acid, or CH3CO2H, to release carbon dioxide gas, which is what causes the volcano to erupt. The relevant chemical equation is NaHCO3 plus CH3COOH CH3COONA and CO2 plus H2O.
What is the elementary reaction?
Single step in a chemical reaction.
Leloir, Argentina, win the Nobel Prize for Chemistry?
For his discovery of sugar nucleotides and their role in the biosynthesis of carbohydrates. Leloir discovered a substance essential for the transformation of one sugar into another. And this turned out to be a sugar bound to a nucleotide molecule, a sugar nucleotide. He soon realized that he had opened the door to a vast number of unsolved problems surrounding carbohydrate synthesis, and proceeded to pursue them with fervor. During his career, Leloir revolutionized the understanding of the synthesis and biosynthesis of sugars.
Is it possible to split an atom?
It is possible to split an atom. When people refer to splitting an atom, it's the nucleus of the atom that is being split. One process that splits the nucleus of an atom is called fission, which can happen spontaneously in heavier elements. Spontaneous fission basically involves a nucleus emitting a particle containing one or more protons or neutrons. One of the most commonly emitted particles is called an alpha particle, which consists of 2 neutrons and 2 protons. Whenever the number of protons in a nucleus changes, it becomes a different element. Nuclei can also be split intentionally in laboratories. The nucleus is held together very tightly, so it usually takes a high-energy particle colliding with an atom to break it apart. Typically a high-energy neutron is used to initiate the process of splitting a nucleus. This process results in an overall release of energy so that once one nucleus is split, its products can cause the reaction to happen again. This is called a chain reaction, and it can be used to produce energy in a nuclear reactor. If it happens somewhat slowly, or an explosion, if it happens quickly.
What is mass spectrometry?
Mass spectrometry is a method of chemical analysis that involves determining the molecular mass of charged particles by measuring the mass-to-charge ratio of an ionized molecule or molecular fragment. There are several ways of performing mass spectrometry, but the general procedure involves making the sample into a vapor, ionizing the sample, and then detecting the ions that form in a way that separates them according to their mass-to-charge ratio. After being ionized, the molecules in the sample will often fragment into smaller ions, and these too are detected according to their mass-to-charge ratio. This technique can be useful for carrying out an accurate determination of the mass of a molecule, as well as for obtaining structural information about molecules via their fragmentation patterns. It also allows the elemental composition of a sample to be determined.
What are some applications of thin films?
Thin films are layers of material ranging in thickness from nanometers, 10 to 9 m, to micrometers, 10 to 6 m. They are used commonly for coating optical surfaces and also for coatings on semiconductors. Thin films are used to make mirrors, and these can be finely tuned. In terms of their composition and thickness, to obtain optical surfaces with a wide variety of specific reflection properties, such as wavelength-specific mirrors and two-way mirrors. The ones that are transparent from one side but reflective from the other. Thin films are also very useful for coating semiconductors to tune their conductive properties for different applications.
What are the valence orbitals of transition metals?
The transition metals are also referred to as the d block because their valence orbitals are the d shell. See illustration on this page. There are 5 different d orbitals. 3, dxy, dxz, and dyz, of these 5 look similar, just with different orientations in space. The fourth, dx2y2, has the same shape as the previous 3. But the loops point in along the axes as opposed to between them. Finally, the dz2 looks like a p orbital pointed along the z-axis with a ring. Technically a torus, around it.
What is polymorphism?
Polymorphism is the capacity for a compound to exist in different crystalline arrangements. This can arise due to different packing of the individual units of the crystal, or due to different conformations of the molecules making up the crystal.
What is ductile?
Pliable, not brittle, a metal that can be drawn into a thin wire.
What is a reactant?
A compound that is consumed or transformed by a chemical reaction.
Why did Rudolf A. Marcus, United States, win the Nobel Prize for Chemistry?
For his contributions to the theory of electron transfer reactions in chemical systems. Marcus received the prize for his work studying electron transfer reactions and developing the theory surrounding this elementary chemical process. The transfer of an electron between two molecules is a ubiquitous process in chemistry, and it is important to a wide range of chemical phenomenon, ranging from the conduction properties of materials to chemical synthesis, to the capture of light by plants for the purpose of harvesting energy. Marcus completed much of the work surrounding the theory of electron transfer in the 1950s and 1960s. And he was able to explain the greatly varying rates of electron transfer observed in different chemical systems. Some aspects of his theories were difficult to confirm experimentally, and were not proven until the 1980s. Which contributed to why it took so long for him to receive the Nobel Prize for his work.
Why did Harold Clayton Urey, United States, win the Nobel Prize for Chemistry?
For his discovery of heavy hydrogen. Urey received the Nobel Prize for isolation of deuterium. D2, by distilling a sample of liquid hydrogen multiple times. He is perhaps better known, amazing that he's better known for something other than what he received the Nobel Prize for his work on the Manhattan Project. Working at Columbia, Urey and his team developed a method for enriching uranium by gaseous diffusion. Finally, after World War II ended, at the University of Chicago, Urey and Stanley Miller, one of his graduate students, showed that a mixture of water, ammonia, methane, and hydrogen could produce amino acids by exposing the mixture to electricity. The experiment was designed to simulate conditions in the early days of our planet, and clearly showed that organic molecules that form the basis of all life can be made from basic inorganic building blocks. And a little spark. After Urey's death, it was shown that over 20 different amino acids were present in the mixture. An even more remarkable result than Urey and Miller claimed in their initial publication.
What is the role of photochemical reactions in green chemistry?
Photochemical reactions can often serve as excellent choices for green synthesase. One reason for this is that a photon, unlike chemical catalysts or reagents, leaves behind no waste or excess atoms. Photochemically initiated reactions can often proceed rapidly at ambient temperatures. Since photoexcitation can be used to generate highly reactive species. In some cases, photochemical synthesase can also reach the synthetic target in fewer steps than those which rely on thermally initiated reactions.
What is temperature?
A physical property of matter that describes the average kinetic energy of molecules.
What is UV/Vis spectroscopy?
Electromagnetic radiation in the ultraviolet and visible region of the spectrum. 40 to 1000 Thz is higher in frequency, and thus energy, than that in either the microwave or infrared. This makes it a good match for the larger energy level spacing associated with transitions between electronic energy levels. UV/Vis spectroscopy can be used to study molecules in any phase. However, it is most commonly used for liquid samples.
What is an enzyme?
An enzyme is a protein whose function is to serve as a catalyst for a chemical reaction within a biological system. Some functions that enzymes perform are the synthesis of proteins and other biomolecules, digestion of fats and other molecules, and sometimes they are even put to use in industrial applications outside of their natural biological environment.
How does sunscreen work?
Sunscreens either reflect or absorb ultraviolet light from the sun. To reflect the light, sunscreens contain either titanium or zinc oxides, which are both very white solids, so all wavelengths of visible light are being reflected. To absorb light, sunscreens can contain organic chemicals that interact with harmful UV wavelengths. While almost all sunscreens use titanium and/or zinc oxides, the particular organic compounds that are used vary widely across brands and countries.
What are the basic units of pressure?
Unlike units of length and temperature, pressure is reported in at least 6 common units. The Pascal, abbreviated Pa, is the official standard unit, but bar, millimeters of mercury, mmHg. Standard atmospheres, atm, torr, and pounds per square inch, psi, are all used in different areas.
What is diamagnetic?
A material that creates an opposing electric field in response to an applied electric field.
What is an amphoteric molecule?
An amphoteric molecule is one that can act as either an acid or a base. Either the Lewis or Bronsted definition of acid/base. Behavior can be used to define a species as amphoteric.
What is Coulomb's law?
Coulomb's law tells us the force experienced by a pair of separated charges. It's a fundamental equation in the study of electrostatics, which is a broad area of physics concerned with the interactions between stationary charges. The key features of Coulomb's law are that it predicts an attractive force between particles of opposite charge and that this force decreases with the square of the distance between the particles. For chemistry, it's relevant to point out that the force between charges falls off rather slowly with the distance between them, so where charges are present in relatively dense materials, like liquids and solids, they have a significant effect on their environment.
Why did Linus Carl Pauling, United States, win the Nobel Prize for Chemistry?
For his research into the nature of the chemical bond and its application to the elucidation of the structure of complex substances. Pauling made significant progress toward understanding the nature of chemical bonds, which are, obviously, relevant to virtually all chemical processes. he proposed the property of electronegativity as a means for characterizing chemical bonds. And he developed a scale for electronegativity values. Pauling's work with X-rays also uncovered the structures of numerous molecules, and paved the road for X-ray diffraction as a characterization method for even more complex molecules. In 1963, Pauling also was awarded a Nobel Peace Prize. Throughout his career, Pauling was always known for working and living at the forefront of scientific discovery.
What makes a rubber band stretchy?
Rubber bands are made of long polymer molecules. These are all tangled together, and you could think of them as being similar to a bunch of interwoven springs. The polymers can be stretched to a more extended state, which is what allows a rubber band to stretch without breaking. More accessible configurations exist, however, when they are in a more contracted state, which means that the more contracted states have higher entropy. See physical and theoretical chemistry, and for this reason are more favorable. This is what makes the rubber band want to contract and is what gives rise to its elasticity. Check out polymer chemistry for more questions on polymers.
What is cream of tartar?
Cream of tartar is the potassium acid salt of tartaric acid. This means one acidic hydrogen of tartaric acid is replaced with a potassium ion. The structure is shown below. If you've ever seen crystals of something in a bottle of wine, or even fresh grape juice, it was probably this chemical.
Why did Osamu Shimomura, Japan, Martin Chalfie, United States, and Roger Y. Tsien, United States, win the Nobel Prize for Chemistry?
For the discovery and development of the green fluorescent protein, GFP. These three scientists received the prize for their work with the protein simply called green fluorescent protein, or GFP. This protein was first observed way back in 1962 in a jellyfish. It eventually became a very important molecule in the biological sciences, as clever researchers have found ways to use GFP to study otherwise invisible chemical processes. Shimomura, Chalfie, and Tsien were at the forefront of the major discoveries that led to the understanding of GFP that researchers possess today.
Why did Roger D. Kornberg, United States, win the Nobel Prize for Chemistry?
for his studies of the molecular basis of eukaryotic transcription. In order for DNA to be read for the purpose of producing a protein, there are a couple of key steps that must take place. Kornberg received the prize for his work to elucidate the details surrounding the first key step, transcription. Transcription involves making a copy of the DNA, which is to be transferred outside the nucleus of the cell. Interestingly, Roger Kornberg's father, Arthur Kornberg, also received a Nobel Prize in Physiology or Medicine in 1959 for his work studying how information is transferred from one DNA molecule to another. Who would have thought that his son would go on to win a Nobel Prize for a very related piece of research?
What is a compound?
A substance composed of more than one element.
What is a cellular organelle?
An organelle is a compartmentalized subunit with a living cell that carries out a specific function. Organelles are separated from the rest of the cell by a lipid bilayer membrane that allows it to maintain different concentrations of solutes from the rest of the cell.
What is a quark?
Quarks are the fundamental particles that make up protons and neutrons, as well as several other types of particles. There are 6 types of quarks, which are referred to as different flavors. These are named up, down, top, bottom, charm, and strange. Protons and neutrons are each made up of 3 quarks. 2 up and 1 down quark make up a proton. 2 down and 1 up quark make up a neutron.
How many phases can be in coexistence?
A rule called the Gibbs phase rule tells us how many phases can be in coexistence for a given substance or mixture. The rule arises from the fact that, to be in coexistence, a constraint exists that the chemical potentials of each component in each phase must be equal. After some math, one can find a relationship between the number of components of a system, the number of free variables, such as temperature, pressure, or the fraction of a given component present in a mixture, and the number of phases that can be in coexistence. This relationship is, F equals Cp plus 2, where F is the number of degrees of freedom. C is the number of independent components, and P is the number of phases.
What is the intensive property?
a property that does not depend on the amount of a substance present, e.g., density, temperature, color.
What is a cation?
A positively charged ion.
What is HDPE, high-density polyethylene?
High-density polyethylene is technically any polyethylene with a density of 0.93 to 0.97 g/cm3. The density in polyethylene is controlled mostly by the number of branch points along the polymer chain. HDPE has very few branches, so the chains can stack together very closely. This tight packing makes it a very strong polymer. So it's used to make things like bottle caps, milk jugs, and hula hoops.
How can I study the effects of acids and bases on sliced fruit getting old and turning brown?
Chemistry principles encountered in this experiment: acids and bases, biochemical/enzymatic reactions, materials you'll need. An apple, other fruits like bananas, pears, or peaches will also work. 5 clear plastic cups vinegar, lemon juice, baking soda, water, milk of magnesia, measuring cups. The procedure: prepare aqueous solutions of milk of magnesia and baking soda. The amount of water you use isn't particularly important. Feel free to test various concentrations if you'd like. The key aspects are that the baking soda dissolves completely and that the milk of magnesia solution becomes less viscous or thick. Slice your apple, or other fruit of choice, into 5 pieces. If you have decided to test multiple concentrations of baking soda or milk of magnesia solutions, adjust the number of fruit slices accordingly. Label the cups as follows: vinegar, lemon juice, baking soda solution, milk of magnesia solution, and pure water. Place 1 slice of fruit in each cup. Add about degree of a cup of the appropriate solution to each of the cups you have labeled. The fruit should not be completely submerged in the solutions, but make sure each slice of fruit gets completely coated with the solution. The vinegar and lemon juice solutions serve as acidic solutions, of acetic and citric acids, respectively. The baking soda and milk of magnesia solutions serve as basic solutions of sodium bicarbonate and magnesium hydroxide, respectively, while the water serves as a neutral control solution. Write down your observations regarding the physical appearance of each piece of fruit at this time. If you have a camera handy, it might be useful to take a picture of your fruit samples for comparison to the final results. Allow the fruit to sit for 1 day, and then come back and record your observations again. If you took a picture on the first day, you can compare the current appearance of the fruits to your photograph. Apples and fruits turn brown when an enzyme called tyrosinase, refer back to chemistry in the kitchen, carries out a chemical reaction in the presence of oxygen and phenol-containing compounds.
What is a mole fraction?
The amount of a substance in moles divided by the total number of moles present.
What is the difference between artificial and natural flavoring?
The difference between calling a molecule artificial or natural is a legal definition, not a chemical or biological one. If a molecule of vanillin is isolated in a lab by extraction of a particular seed pod, the chemical is called natural vanilla. If that same molecule is made from lignin, which is a polymer found naturally in wood, that substance is called artificial vanilla. The difference is that transforming lignin to vanillin requires chemical steps not covered by the legal definition of the word natural. To be clear, the natural and artificial versions of a molecule are exactly the same chemical species. Same atoms, same bonds, same stereochemistry, etc. But there may be other chemicals present that may differ in the natural and artificial versions of a product. So is natural vanilla worth the extra money? Well, that's a different question. When the seed pods of the Mexican orchid Vanilla planifolia are collected, they are put through an elaborate series of curing and aging steps. These steps allow additional flavor molecules to develop beyond just vanillin. While vanillin is a major flavor component of natural vanilla, there are hundreds of other tasty chemicals in natural vanilla. So you're not buying exactly the same thing when you buy artificial and natural vanilla. Which one tastes better in your cookies is up to you, though.
What are the wavelength and frequency of light?
The light we see is a form of energy called electromagnetic radiation. It may sound like something complicated, but it's nothing too exotic or unfamiliar. Everything you see is because of electromagnetic radiation. Electromagnetic radiation consists of perpendicular electric and magnetic fields that oscillate in amplitude. The number of times per second that the fields oscillate is the frequency of the radiation. This is measured in hertz, or inverse seconds. The wavelength is the distance that the light travels through space during one oscillation of the electric or magnetic field.
What is precipitation?
Precipitation is the formation of a solid in a solution. This happens when a substance has too low of a solubility to remain dissolved in the solution. This process can occur for a variety of reasons, such as when a new product of a chemical reaction has low solubility or when a temperature change takes place. Precipitation begins when a small crystal begins to form, which is part of a process called nucleation.
What fifth element did Aristotle add?
Although Empedocles is understood to have been the first to propose the four basic elements, Aristotle is sometimes given this credit. Aristotle did propose a fifth basic element though, which he called ether. Ether was a divine material that Aristotle said made up the stars and other planets in the sky.
Why does iron rust?
Rust is iron that has been oxidized. The oxidation of iron, or any iron alloy, see History of Chemistry, can occur whenever iron is in the presence of oxygen and water. The chemical reaction involves electrons from the iron being transferred to oxygen atoms, which react with water molecules to eventually form iron oxides. The presence of ions, like salt or H3O and in acidic solutions, can accelerate the rate of these reactions. Preventing rust usually requires a protective coating that prevents the iron from reacting with oxygen and water.
What is removed from butter to make clarified butter?
Proteins and water. Clarified butter is made by melting regular butter at a low temperature. 3 layers will form. The top frothy layer contains the proteins from milk, casein, used to make cheese. The middle layer is water with dissolved milk sugars, like lactose. The bottom layer is pure butterfat or milk fat, which is also known as clarified butter. You can instead heat butter at a low temperature for a long time to remove the water by evaporation, and then decant or filter the butterfat. Clarified butter contains almost no proteins, so it has a very long shelf life. And no lactose, so people who are lactose intolerant can eat it.
What happens when you add sodium metal to water?
Sodium metal reacting with water can produce a violent response. Sodium and water react according to the equation, 2Na(S) plus 2H2O, L. 2NaOH, Aq, plus H2, G, plus heat. As you can see, this reaction produces heat. And it turns out that the amount of heat produced can be pretty substantial. The heat can even cause the hydrogen gas, produced in the reaction, to ignite. Thus reacting according to this equation, H2, G, plus O2, G, H2O, G, plus heat. The heat produced by both of these reactions can even cause any currently unreacted sodium metal to also ignite and burn according to the equation. Na, S, plus O2, G, Na2O2, S, from these reactions. It is probably clear that the reaction of sodium with water can produce quite a lot of heat.
What is a monodentate ligand?
A monodentate ligand is a ligand that coordinates to a metal center via a single atom on the ligand.
Why did Lars Onsager, United States, win the Nobel Prize for Chemistry?
For the discovery of the reciprocal relations bearing his name, which are fundamental for the thermodynamics of irreversible processes. Onsager received the prize for his brilliant mathematical work that allowed for a theoretical description of irreversible processes. He additionally made a large number of other contributions to physics and chemistry during his career, including developments surrounding the conductivity of solutions and flow of electrolytes, and a solution to the Ising model.
What is accuracy?
Accuracy is used to refer to how close a measured value is to the true value of the quantity. This is pretty simple to understand. For example, if the true temperature in the room is 20 degrees Celsius and a thermometer reads 20 degrees Celsius, the measurement is pretty accurate. If the thermometer read 0 degrees Celsius, the measurement is not very accurate.
Why did Johann Diefenhofer, Robert Huber, and Hartmut Michel, all Federal Republic of Germany, win the Nobel Prize for Chemistry?
For their determination of the three-dimensional structure of a photosynthetic reaction center. This prize was awarded for the atom-by-atom characterization of a membrane-bound protein, and, in particular, one that is responsible for carrying out photosynthesis. These proteins are quite difficult to crystallize, and Michel can be credited with achieving this task. He then collaborated with Huber and Diefenhofer to unravel the details surrounding the structure of the crystallized membrane-bound photosynthetic reaction center.
What are some common units of concentration for a species in solution?
The most common unit of concentration in solution phase chemistry is molarity, or the number of moles of a species present per liter of solution. Recall that the number of moles of a species is equal to the number of molecules of that species divided by Avogadro's number. See History of Chemistry for information on Avogadro's number. In analytical chemistry, it can often be more convenient to discuss concentrations in terms of other units. This is particularly true when the species being studied is present in very small concentrations. Some other commonly used units are parts per million, ppm, parts per billion, or parts per trillion. These units refer to the mass fraction of the analyte in question to total mass of the sample. 1 part per million means 1 millionth, 10 to 6, of a gram of the species in question. Or analyte, per gram of the sample present. Similarly, 1 part per billion means 1 billionth, 10 to 9, of a gram of analyte per gram of sample. And 1 part per trillion means 1 trillionth, 10 to 12, of a gram of analyte per gram of sample. It is also possible to use each of these definitions based on a per unit volume basis, rather than a per unit mass basis, though this is more common in the gas phase. For example, 1 ppm by volume of an analyte means the analyte occupies 1 millionth, 10 to 6, of the total volume of a sample.
Why is the process of manufacturing ibuprofen an excellent example of green synthesis?
The modern industrial-scale synthesis of ibuprofen has very high atom efficiency, and it has been modified from the original synthesis to be both more environmentally friendly and more cost-effective. The original method involved 6 synthetic steps but used stoichiometric, as opposed to catalytic. Quantities of reagents had lower atom efficiency, and produced undesirable quantities of waste. The modern alternative, on the other hand, requires just 3 steps, each of which is catalytic in nature. The first step employs a recyclable catalyst, hydrogen fluoride, HF, and produces almost no waste. The second and third steps each achieve 100% atom efficiency, wow! This process truly represents an ideal benchmark for excellence in green synthesis on the industrial scale.
Why does asparagus make pee smell weird?
The compounds you smell in your pee after eating asparagus are most likely thioethers. Although the literature over the last 100 years on this subject includes some debate, no joke. That's a sulfur atom with 2 carbon substituents. Asparagus, for some reason, has high levels of sulfur-containing amino acids. Your body breaks these down into chemicals that smell like rotten eggs or other foul odors.
How does non-stick cooking spray work?
It's not nearly as magical as you might think. Cooking spray is just regular vegetable oil in spray form. To get it to spray out a fine mist, an emulsifier is added. And the can needs something to act as a propellant, usually alcohol, CO2, or propane.
How is a band gap relevant to the design of photovoltaic materials?
The band gap of a material determines what wavelengths of light a photovoltaic or any other material can absorb. Photovoltaic materials need to be capable of absorbing the wavelengths of light that the sun emits. And this requires that they have a band gap that spans the appropriate range of energies.
How do those new scanners at airports work?
There are two main types of these scanners. One uses radio waves to generate a three-dimensional image of what's underneath a person's clothes, while the other uses low-intensity X-rays to generate a two-dimensional image. Both of these techniques rely on measuring the radiation that is scattered back off of one's body to generate an image. The purpose of these scanners is to look for basically the same things a security officer would look for in a pat-down. Weapons, explosive devices, or anything else someone is trying to hide.
Why did Robert J. Lefkowitz and Brian K. Kobilka, both United States, win the Nobel Prize for Chemistry?
For studies of protein-coupled receptors. Lefkowitz and Kobilka shared this prize for their work studying a class of receptors called G-protein-coupled receptors. These play a role in how cells sense their environment, and especially in how cells respond to medicines, hormones, and other signaling molecules. Lefkowitz had been working in this area since the late 1960s, and Kobilka since the 1980s. But it wasn't until 2011 that they were able to get an image of the receptor at the exact moment that a hormone activates its signaling mechanism. The prize was awarded for their collective body of work elucidating how these receptors function.
What is a carbohydrate?
Organic compounds of carbon, hydrogen, and water. Typically with hydrogen and oxygen in a 2:1 ratio, respectively, these are often called sugars.
What is the third law of thermodynamics?
The most common statement of the third law of thermodynamics is that the entropy of a perfectly crystalline system approaches zero as the temperature of the system approaches zero. Recall from macroscopic properties. The world we see that a perfect crystal is a regularly ordered lattice of atoms that exist in a repeating pattern in 3 dimensions with no defects or irregularities in the lattice. This is equivalent to saying that a perfectly crystalline system has only one accessible state as the temperature approaches zero. In truth, this isn't always strictly true since there can be multiple low energy states that all have the similar energy, but let's ignore this for now.
What is cold fusion?
A cold fusion reaction is one that takes place under ambient conditions using simple equipment. Such a fusion reaction would be extremely desirable, since it could allow for a simple and efficient means of energy production.
What is nonpolar?
A molecule in which the distribution of charge does not lead to an overall dipole moment.
How could algae potentially be used as a source of energy?
Algae are potentially a very useful source for biofuels. But currently the cost of using them as a source of biofuels is too high to make them practically useful. One current area of research involves using the algae biofuel production process to produce a byproduct that is rich in protein and that could be used to feed farm animals. This would help to offset the cost associated with algae biofuel production. Since corn is currently used to both feed animals and to produce ethanol for fuel, the protein-rich byproduct could also help by reducing the amount of corn that needs to be grown. Cars can run on an ethanol-gasoline mixture with 10% ethanol. E10, but to use an 85% ethanol mixture, E85, requires a specially designed system. Ethanol burns much cleaner than gasoline, making it less hazardous to the environment. It is also a renewable resource that can be produced by growing crops. So it has the potential to reduce dependence on foreign oil sources.
What is the yield for a reaction?
The yield of a chemical reaction is the amount of product that is produced. An example might be 2 grams. It is often of greater interest to consider the percent yield, which describes the amount of product formed relative to the maximum amount of product one could have expected based on the quantities of reactants used. The percent yield provides a measure of how efficient a process is for producing the target product.
What causes non-stick pans to be non-adhesive?
Non-stick pans and other surfaces are coated with a polymer that does not interact strongly with other surfaces, hence, no sticking. Teflon, R, developed by DuPont, R, in the 1940s, is most frequently used for this application. Teflon, R, is a polymer of tetrafluoroethylene, which is very hydrophobic. So water or any other substance, like food, doesn't stick to it. More recently, other polymers have also been developed for this application. Thermalin, R, is a silicon oxide polymer with some similar properties to Teflon, R. And Ecolon, R, is a nylon-based product that is reinforced with ceramics for toughness.
What is pyrophoric?
A substance that tends to ignite readily and spontaneously upon exposure to air.
What is absorption?
Capture of one material into another, can be a physical or chemical.
What is process accuracy?
Closeness of a measurement to the actual or accepted value.
What is meta?
Term used to describe two substituents on an aromatic ring that are separated by one position. I.e., 1,3 substituted.
How is radiation used in medicine?
We should begin by pointing out the distinction between radiation used in nuclear medicine / radiopharmaceuticals, more akin to the other topics of this chapter, and electromagnetic radiation, light of different wavelengths. Nuclear medicine is the branch of medicine most closely tied to the concepts of nuclear chemistry discussed in this chapter. Diagnosis via nuclear medicine typically involves the injection of a radiopharmaceutical into the body. And the radiation released by this drug can then be monitored to gain information about organ function. Blood flow, the location of a tumor, or to locate a fractured bone. In some cases, the use of nuclear medicine can allow for earlier diagnosis than with other imaging techniques. In terms of using electromagnetic radiation for medical applications, perhaps one of the first treatments that come to mind is radiation therapy, which is used to fight against a broad range of cancers. This involves using focused electromagnetic radiation to damage the DNA in the tissue of a tumor while hopefully not causing too much damage to the surrounding healthy tissue. The goal is to damage the DNA of cancerous cells so that they are unable to reproduce, hopefully killing the tumor with time. Beams of radiation are focused onto the tumor from different angles to minimize the effect on any one area of healthy tissue. Rays and CT scans are two commonly used, non-invasive medical techniques that make use of electromagnetic radiation to take pictures of what's going on inside the human body. It should be noted that prolonged exposure to the X-rays used in these procedures can be harmful and are capable of causing cancer themselves over long periods of time.
What is styrofoam? R.
Styrofoam, R, is a brand name, owned by the Dow Chemical Company, for expanded polystyrene foam. It's 98% air, which is why those styrofoam, R, coffee cups are so light, and actually buoyant. In addition to disposable food containers, polystyrene foam is used in building and pipe insulation. Packing peanuts, and that green stuff they use for holding together fake flower arrangements.
What is galvanization?
Application of a thin layer of zinc metal to steel or iron, which prevents the formation of rust.
Does reaction stoichiometry also apply to electron transfers?
Yes, for just the same reasons it applies to chemical reactions. The conservation of matter tells us that we must have the same amount of stuff before and after a reaction has taken place, so the number of electrons on each side of a chemical reaction equation need to be balanced for the equation to be accurate.
What is hydrolysis?
The breaking of chemical bond, S, by the addition of water to a molecule.
What is a kinase?
An enzyme that catalyzes phosphorylation, transfer of a phosphate group.
What is the valence shell of electrons?
Electrons fill up orbitals in shells. The innermost shell consists of just one s-type orbital and can hold just 2 electrons. The next shell consists of one s-type and 3 type orbitals, and can hold 8 electrons. Higher shells consist of more and more orbitals and can thus hold more and more electrons. The valence shell of electrons is the highest occupied, or partially occupied, set of orbitals.
What is the breakdown for fuel source usage globally?
Roughly 32.4% of the world's energy is used in the form of oil. About another 27% comes from coal sources, and another 21% from natural gas. Together, these three sources account for a total of over 80% of the energy sources used globally. The remaining 20% comes primarily from combustible renewables and waste. 10%, nuclear energy, 6%, and hydroelectric sources, 2%. As you can see, some of the commonly discussed green energy sources, like solar energy or energy collected by wind turbines, do not yet make significant contributions to the breakdown of energy sources commonly used on a global scale.
Do all isotopes of an element decay at the same rate?
No, actually each isotope decays at a unique rate. The most radioactive isotopes are those isotopes which decay most quickly. There are some elements, especially the heaviest ones, that don't have any truly stable isotopes. And these can only be synthesized for fleeting amounts of time in laboratory settings.
What causes addiction to a substance?
Drugs that cause addiction change the ability of receptors in your brain to cause you to feel pleasure. There are a few ways this can happen. Depressants often work by increasing the affinity of a receptor for a small molecule called GABA. Gamma-aminobutyric acid. Stimulants make you feel happy or better than you would otherwise. They can do this in a few different ways, but two common ones are to either cause more dopamine to be released or to prevent the reabsorption of dopamine so that it stays around and keeps you happy for longer. Narcotics act in a similar manner to stimulants in that they mimic the molecules that make you happy normally.
What is the Warner Babcock Institute for Green Chemistry?
The Warner Babcock Institute for Green Chemistry was founded by John Warner and Jim Babcock to promote the development of environmentally safe and sustainable technologies. The institute offers training in the principles of green chemistry for both scientists and non-scientists alike. Hydrogen peroxide is an ideal green reagent, including the fact that it is relatively inexpensive and is produced in mass quantities. In fact, 2.4 million metric tons of hydrogen peroxide are produced each year. One matter of concern is that high concentrations of hydrogen peroxide can be dangerous. So reactions should be run at concentrations of less than about 60% H2O2.
Why did Victor Grignard, France, win the Nobel Prize for Chemistry?
For the discovery of the Grignard reagent and Paul Sabatier, France. For his method of hydrogenating organic compounds in the presence of finely disintegrated metals. Grignard was recognized for his preparation and study of organic magnesium compounds. RMGX, which he prepared from organic halides, RX, and magnesium metal. He discovered that these magnesium reagents can react with carbonyl groups to form new carbon-carbon bonds. Sabatier shared the prize in 1912 with Grignard for his work on hydrogenation, or the addition of a molecule of H2 to an organic molecule. Sabatier observed that nickel acted as a catalyst for these reactions. The Sabatier process, the reaction of Co2 and H2 to form CH4 and H2O, continues to be a useful reaction, and NASA is investigating it as a means to generate water from Co2 waste, from exhaling astronauts.